So in example 2 here, we're going to apply the distributive property to multiplying radicals together. So it's kind of like the paperboy method that we've used before. This paperboy has to deliver to house number 1 and to house number 2. So we're going to need to multiply the square root of 3 by the square root of 6, and also multiply the square root of 3 by the second house, the square root of 12. And then add our answers. So square root of 3 times square root of 6 is square root of 18. And square root of 3 times square root of 12 is square root of 36. Now we have to make sure that both of our radicals are completely simplified. So we've got to look at our perfect square list, 2 squared, 3 squared, 4 squared, and so on in the upper right-hand corner, and find the largest perfect square that divides into each of these. For 18, that's 9. So the square root of 18 can be broken down to the square root of 9 times the square root of 2. The square root of 36 is 6. So no breaking down necessary. It just simplifies completely to the whole number 6. And now we know that the square root of 9 is 3. So we get 3 root 2 plus 6. And there's no more simplifying that can be done because root 2 does not have a perfect square that divides evenly into it. So let's look at example B. Our paperboy 2 root 2 has to deliver papers to both the 4 root 3 and to the minus 5 root 6. So we can multiply the coefficients. 2 root 2 times 4 root 3 would be 2 times 4, or 8. And root 2 times root 3 is root 6. Now the second house, but I've got a minus on this one. 2 times 5, the coefficients, is 10, and root 2 times root 6 is root 12. Then we need to make sure that we do not have any radicals that can be simplified further. Well, square root 6, there are no perfect squares that divide evenly into it. But root 12 has a perfect square of 4 that divides evenly into it. So I can break down root 12 into root 4 by times root 3. And root 4 is 2, so root 12 ends up being equal to 2 root 3. Now that 2, though, has to be multiplied by the 10 that is already out in front. So I have 10 times 2, which is 20 root 3. With a minus in front, that stays. And then the 8 root 6 out in front could not change any further. So my final answer is 8 root 6 minus 20 root 3. All right, so now let's introduce some variables. In C, we're going to distribute the root 6x to both the root 8x and the root 12xy. So we're going to take root 6x and multiply it by root 8x, and then we're going to take the root 6x and multiply it by root 12xy. So starting here with root 6x times root 8x, we can just multiply those together. Root 6 times root 8 is root 48, and x times x is x squared. With our second house, root 6 times root 12 is root 72, and root x times root xy is root x squared y. And that plus stays in front. So now we have to think about our perfect squares. We have our perfect squares for coefficients, but remember, from class the other evening, perfect squares for variables are variables that have an even exponent. So if we look at the number 48 in our first radical, The largest perfect square that divides evenly into 48 is 16. 16 goes into 48 3 times. So I'm just breaking apart the 48 into 16 times 3, or in other words, the root 48 into root 16 times root 3. X squared has an even exponent, so it is a perfect square. Now let's break apart the second radical in blue. The largest perfect square that divides evenly into 72 is 36. 72 divided by 36 is 2. So I have square root 36 and I have square root 2. The x squared has an even exponent, so it's already a perfect square. But the y is to the first power. It does not have an even exponent, and there is no even exponent less than 1, the current exponent, that is a perfect square. So that will not be able to be simplified any further. So now, with our first term, the square root of 16x squared is 4x, because the square root of 16 is 4, and the square root of x squared is x to the first. Remember, we take the exponent and divide by the root. 2 divided by 2 is 1. And then we have to keep that square root 3 as a part of our answer. It cannot be simplified any further. So now the second part. Square root 36 is 6, and square root of x squared is x. That square root of 2y just has to remain under the radical. And so our final answer is just 4x root 3 plus 6x root 2y. So here in part D of example 2, we have to start in the very same manner. We have to distribute the paperboy cube root 2 to both. So when I multiply the cube root 2 by the 5 cube root 4, I have a 1 in front of this cube root, so 1 times 5 is 5. And then cube root 2 times cube root 4 is cube root 8. Now the second household, 1 cube root 2 times negative 3 cube root 16. I'm going to take the coefficients and multiply them together. 1 times 3 is 3. And then I'm going to take my cube roots and multiply them together. Cube root 2 times cube root 16 is cube root 32. Now I've got to see if my cube roots can be simplified. So think about our list of perfect cubes: 2 cubed, 3 cubed, 4 cubed, and so on. 8 is a perfect cube already, and therefore cube root of 8 can be simplified to a nice whole number. It is 2, because 2 times itself 3 times is equal to 8. So now I have 5 times 2 for my first term. The second term, 32, is not a perfect cube, but it does have a perfect cube that divides evenly into it, and that is 8. 8 times 4 is equal to 32, so the cube root of 8 times the cube root of 4 is equal to the cube root of 32. And once again, cube root of 8 is 2. So I have to bring it out and multiply by the number that's already out in front of that radical, which is the minus 3. The cube root of 4 is going to need to stay underneath the radical. So what I have now is, when I multiply 5 by 2, I get 10. When I multiply 3 by 2, I get 6, and then that 6 is attached to the cube root of 4. Since there is no perfect cube that divides evenly into 4, That is my final answer, 10 minus 6 times the cube root of 4.